Hi everyone. Today I'm going to discuss measure of variation, or we call measure of spread. So, in the first place, what is this measure of variation? There are three things include into measure of variation: range, standard deviation, and interquartile range. So these three we call measure of variation. First, we are going to look at range. What is range? Range of a data set. The range of a data set is given by the difference of maximum value and minimum value. So range is maximum minus minimum value. Standard deviation. Next one is standard deviation. Standard deviation measures the variation by indicating how far on average the observations are from its mean. So how far, let's say this is my mean, this is my mean. So how far the observations are from the mean, something like this. So we call this standard deviation. This standard deviation takes into account all the observations, same as mean. The standard deviation consider all the observations what we have. It is preferred the measures of the variation when the mean is used as the measure of center. In any case, if we are using mean or average as a measurement, then we can use the standard deviation. Because if you remember, when we consider mean, sometime we have outliers, so that mean is not a good measurement. But if we don't have outliers, we can use mean, then we can use standard deviation too. Variation and standard deviation. So what is these two terms? Variation is the spreadness from data from its mean. Standard deviation is the square root of variation. The more variation that there is in the data set, the larger is its standard deviation. So it has this very similar this kind of relationship. So standard deviation is equal to a square root of variation. It has this kind of relationship. Standard deviation we can calculate by using this simple equation. Standard deviation we denote by simple s. This standard deviation we are considering sample. So sample standard deviation is denoted by simple s and calculated by s equals square root of summation xi minus x bar squared divided by n minus 1. Here n is the sample size, x bar is the mean. Do you remember this one? Summation of xi divided by n. X bar is that value. Actually, you don't need to memorize these equations. You can use a formula sheet, or any other way you can use this. You can use your calculator to get the value. So it doesn't matter, but you should have a better idea how we calculate this sample standard deviation. Okay, variation and the standard deviation. So more variation has more variation has more standard deviation. STD dev, standard deviation. If variation goes up, then standard deviation goes up. Okay, sample standard deviation you can calculate by using this formula as well. This is also similar to the previous one, which is s equals square root of summation xi minus x bar squared over n minus 1. The previous equation, this is also a similar equation for sample standard deviation. Okay, so if you want, you can use this as well. Okay, let's check these two data sets. We have two data sets. They are equal number of sizes, 3, 6, 9, 10. So n equals 10 here. Okay, so mean and standard deviation of this data set, how we calculate x bar? It is summation of xi's divided by n. How we calculate simple s? Summation of xi's minus x bar squared over n minus 1 square root. Okay, so by using these two, you can calculate these values. Okay, so as you can see in these two data set, mean is equal. They have equal mean. They have equal mean, but they have different standard deviation value. Okay, what we have here? Here in this figure, it is a dot plot. So these values in the previous slide, this data set value have mentioned values have mentioned in this dot plot. This is a dot plot. Okay, these are the values. Right now, no need to worry about these. What is this x bar minus x? That just consider only the dot plot. Okay. Okay. Here in this example, you can calculate your standard deviation based on these values. Okay, for an example, I'll do few of them. So this should be xi minus x bar. Okay, okay, xi, this is x1, this is x2, this is x3, this is x4, and this is x5. Okay, so what is x bar? X bar is summation of xi's is 72 plus 73 plus 76 plus 76 plus 78 divided by n is 5. So we have to get this value, and 72, so x1 is 70, this is x1, this is x2, so on, this is x5. So x1 minus x bar, so 72 minus x bar, you know what is this x bar value, so you can plug that value here. 73 minus x bar, so likewise you can calculate this square deviation. How you calculate? You just square this value, you can take the square of this value, and then you can add those values together. Then you have this value, summation of xi minus x bar squared. Okay, so that you can find your standard deviation x by using this. This one is here, divide by n minus 1 square root. So you can find standard deviation. Okay. Okay, next one is three-standard deviation rule. Three-standard deviation rule. What is this three-standard deviation rule? Almost all the observation in any data set, so please remember this, almost all the observation in any data set lie within three standard deviations. Within three standard deviation. What is this three standard deviation? Okay, I'll draw it for you. This is your values. Here it is x bar. What is x bar? It is the mean of the data set. It is the mean. So what is simple S mean? Simple S mean standard deviation. Standard deviation we denote by simple S. So here x bar plus S, mean plus standard deviation. From left hand side, x bar minus s, standard mean minus standard deviation. Again, I can extend this s values like 1s, 2s, 3 times x, 4 times x, something like that. So x bar plus 2 times s. From left hand side, x bar minus 2 times s. Again, x bar plus 3 times s. X bar minus 3 times s. Oh, sorry, 3 times s. So this called 3 standard deviation rule. Okay, x bar minus s, x bar minus 2 times x, x bar minus 3 times x. From left right hand side, x bar plus s, x bar plus 2 x s, x bar plus 3s. So this we call 3 standard deviation rule. This is very important, you will see after a few minutes. Chebyshev rule and the empirical rule. Okay, Chebyshev rule, it says that any quantitative data set and any real number k greater than or equal to 1, which means k greater than or equal to 1, okay, k greater than or equal to 1, at least this much, 1 minus 1 over k square of observations lie within k standard deviations to either side of the mean. Either side of the mean this side or this side from its mean, that is between x minus k, x bar minus k and x bar plus k. So this is x bar, this is x bar plus k, and this is x bar minus k. So in Chebyshev rule it mentioned that this much observation lies within k standard deviation. So how many observations? How many observations? How many obs? 1 minus 1 over k squared. Okay. Okay. Empirical rule. Empirical rule says that any quantitative data set with roughly bell shape, so my data set, shape of my data set is bell shape. The following properties hold. Property 1, approximately 68% observation lie within one standard deviation. What is one standard deviation? X bar plus s or x bar minus s. This is what we call one standard deviation. So there are 68%. Okay. Property 2 says approximately 95 of the observation lies within 2 standard deviation. So within 3 standard deviation we will be having 99.7, which means almost all. So you can see in this picture, this is one standard, this one standard deviation, this one standard deviation. So we have 68%. 2 standard deviation we have 95, and 3 standard deviation we will be having 99.7. Okay. Okay. By using this empirical rule, I have given a very simple problem. Okay, let's see this one. Blood pressure of 18 years old woman is roughly bell shaped. Okay, I'll draw it here. Roughly bell shape. Please consider this as a bell shape. Mean 120 milligram mmHg. Okay, and standard deviation simple s is 12. Okay, s is 12. So this is x bar. Percentage of 18 years old women have a systolic blood pressure between 96 and 144. Okay, so now we have to use what? Empirical rule, which means 1 standard deviation, 2 standard deviation, 3 standard deviation, that rule. Okay, so first we need to figure it out, what is the relationship between this x bar and 96. X bar is 120, 96. So when you check these values, 120 minus 12 is 96. Sorry, not 12, uh, 2 times 120. Okay, 120 minus 2 times 12 is 96. 120 plus 2 times 12 is 144. See, 2 times, what is this 12? This 12 means my S. Okay, this 12 means my S. So this is in 2 standard deviation, right? So this is in 2 standard deviation. This is x bar, this is your x bar plus 2s, this is your x bar minus 2s. So according to the empirical rule, what is the percentage? See, 2 standard deviation, it is 95%. Clear? So this is how we solve problems by simply using this empirical rule. So I hope that you guys have a rough idea about this spreadness or variation of my data, of our data set. So hope to continue this lesson in next video series. So thank you for joining this video, and I'll see you in future videos. Thank you very much and have a nice day.